So this is just going through some of the early questions on paper 2. So AQA paper 2, this is 2021, but most of the paper 2s have quite a few data representation style questions at the beginning. The first one, converting the decimal number 220 into binary. So we need to know our binary positions. So I've put 8 of them down, and the next one I've got on there as well. It's obviously the number's smaller than that. Normally at GCSE they don't ask you to go more than 8 bits. So we can write 220 down, and then we can take away 128, and we're going to get to 92 for that. But you can do that longhand if you like. And you'll still get to 92. So we've got 92 left. So 64 goes into 92. So we're going to take 64 away. So again, we can work this out and arrives at 28. So that means we don't have any 32s because no 32s go into 28, but 16 does. And again, we can do the taking away. We end up with 12. So we're going to have an 8 and a 4 and 2 zeros to make up our 12. So the answer is 1101, 1100. You can obviously check that back if you want to, but we've gone longhand through this and we've worked it out. So in this paper you don't get a calculator, so it's well worth doing some checks. Next one's hexadecimal, so convert AD into binary. So A in hexadecimal is the same as 10, so that means B would be the same as 11, C 12, D 13. There's nothing wrong with writing these down on the paper. In fact, sometimes that actually gets you a mark for recognizing it should you not get the answer correct. So there's nothing wrong with doing that. So then we're going to put them next to each other because that's the way hex is, AD, and we just put our numbers 1, 2, 4, 8 under each one. 1, 2, 4, 8. And D is 13. So 8 and 4 and 1. And A is 10. 8 and 2. So we've got our answer because we're just going into binary. So that's our answer: 1 0 1 0 1 1 0 1. That's conversion hex to binary. So then we've got one just here, which is converting hex 1A into decimal. So we need to go to decimal this time. You can just work with base 16. I tend to take it into binary. It's a simpler process for my brain. So converting the hex number 1A to decimal. So again, A is 10. So we remind ourselves of that. So if we want to go into binary, the first number is 1. So that's 0 0 0 1. And the second one is A, and we'll put our numbers in again. So we've got our binary number 0 0 0 1 1 0 1 0. So we're going to put our positions in. And we're going to add them together. So we've got 16 plus 8 plus 2. And we end up at 26. 26 is the answer. So all we've done is do the same conversion we did up here on this one, but we've just converted it then from the binary number into decimal. So once you've got a binary number, we're going to put the numbers, the binary positions at the top, and then add them together. So then the next question was, what's the largest hex number that can be represented in binary using 8 bits? So obviously, anytime you can pause the video here and have a go at these questions before we come up with an answer. So the largest hexadecimal number that can be represented in binary. So 8 bits, well, our biggest number in hex, it only goes up to F. So we've got F and F, and they would be 1111 and 1111. So the largest hex number is FF. So if you did that into decimal, that would be 255, because that's the result of adding all those ones in binary. So 255. The answer to the question was FF. But if we'd have written it in binary, we'd have almost certainly got the answer there as well. So moving on. Question 2 was, which of the following is a reason why hex is used? Well, the only reason that we know of that hex is used is that it's easier for humans to read, it's easier for humans to understand and use, they make less mistakes, those kind of ideas. So the first answer, computers work in hex, not binary, obviously not wrong, not correct. We know that computers only use binary numbers because they use switches. Hex can be used to represent a wider range of numbers. No, it's the same range of numbers, no difference. Hex is a standard language and binary is not. No idea what that means, it's just made up. Hexadecimal is more compact when displayed on screen. It is a more compact representation. So that's the only one that makes any kind of sense to us. So we're going to shade that one in, trying to carefully shade the middle bit like that. Incidentally, on these questions, if you got one of them wrong, make sure you cross it right through like that. It's needs to be very well crossed through so the computer is marking it can tell. So this is the only valid answer. It's more compact when displayed on the screen. It's more compact when we write it down as well, because as we just looked at in the previous question, FF is definitely more compact than 1111, 1111, although they're the same representation. So we'll go back up here, and this is some binary addition. So hopefully we're getting quite good at binary addition these days, but you can pause and have a go if you like. So it's a 3-number addition. So 3 numbers is the most they'll ever ask you to add. So 0 plus 0 plus 1 is 1. 0 plus 1 plus 0 is 1. 1 plus 0 plus 1, well, that's obviously 2, so we can't put 2, so we put 0 and we carry 1, because the representation in binary for 2 is 1, 0. 0 plus 0 plus 0 plus 1. 1 plus 0 plus 1, well, again, that's 2, so 0 and carry 1. 1 plus 1 plus 1, we've now got to 3, so representation for 3 is 1, 1, so 1, carry 1. 0 and 0 and 0 plus 1 is 1, and we've just got 1 on the end, so the final answer 1, 1, 1, 0, 1, 0, 1, 1. So normally on these questions, when it's 2 marks, you get a mark for the left hand side and a mark for the right hand side.